Um, so without further delay, let me introduce Westin Eckerson. Westin has been a thought leader in the business intelligence field since early 90s. He has conducted numerous research studies and is a noted speaker, blogger, and a consultant. He's the author of 2 widely read books, Performance Dashboards, Measuring, Monitoring, and Managing Your Business. And the recent one, The Secrets of Analytical Leaders, Insight from Information Insiders. For many years, he served as the Director of Education and Research at the TDWI, the Data Warehousing Institute, where he oversaw the company's content and training programs and chaired its BI Executive Summit. Please welcome Westin Eckerson.
Thank you very much, Kai. It was a wonderful introduction. And I've been doing conferences, running and managing conferences for almost 15 years. And I have to say, for a first event, you guys have done a terrific job. So, and it's certainly a pleasure to be here in Detroit. It's been quite a while since I've been here. And I'm in a unique position. Of all the events that I've run myself and spoken at, I've actually never been the last speaker on the docket. So it's a new and wonderful experience, I hope, for me and you. I guess I'm the only person between you and rush hour, right? So you won't mind sitting back and relaxing for a little bit. So I've got about 45 minutes to talk about the big data revolution. And really the goal here for my presentation is to help you understand what big data is, if you don't know already, and more importantly, how it fits into what you've already got on the BI and data warehousing space. So I won't belabor this because Kai did a great job. I will say on the book that I just published this fall, Secrets of Analytical Leaders, I did want to call it Secrets of BI Leaders because that's what my consulting company is called. But you know how it is in the tech space, words get hyped and buzzed. So the new word today is analytics or big data. So I had to pick the modern word. So that's what we're here today. I think the theme of that book overall, and I got together the 7 smartest BI directors that I know and asked them one simple question. What's the secret of running a successful BI and analytics program? And there were a number of things that they said, but one of the overarching themes was deliver value fast by partnering with the business, even to the extent of embedding your analysts and your developers in the business so they sit side by side with them and function as a single team instead of 2 separate teams with different jargons and career paths and vocabulary, which is the state in many organizations. So that's the cliff notes to that book. But I do recommend you read the whole thing. Oh, I gave away my punchline. All right, so every presenter needs to leave the audience with one theme, okay? One message. So my message to you today about big data is this, okay? Big data, big schmata. Have you ever seen anything more hyped in the history of high tech than big data? I haven't. Though I suspect that artificial intelligence may have given this a run for its money in its day. Actually, it was a little bit before my time. But this whole thing about big data, I actually don't get. I mean, I've been in the data warehousing space for 20 years. And we've always been about big data, right? I mean, sure, the scale and scope of what we can do today is different than it was 20 years ago. The types of data we can address today are a little bit different than it was 20 years ago. But otherwise, not much has changed. I mean, what are we really trying to do here? We're trying to, at a strategic level, use data to make smarter decisions. Really? That's all it's about. And that really hasn't changed. And tactically, it's about building 2 different types of applications. Reporting applications and analysis applications. And those are actually 2 very different types of apps that are used by 2 very different constituents in your organization that require different tools and architectures. And not very many people really understand that distinction. And I think the key challenge that you have in being successful in this space is learning, 1, that these 2 poles in BI exist, and 2, how to reconcile them together. And we'll touch on that a little bit today, but I have a whole presentation on that. Now, the other thing about big data that kind of, I guess, peeves me is that data by itself is really useless, right? It's a bunch of ones and zeros, a bit stream. I mean, come on. By itself, data has no business value. And that's what we're about, trying to deliver business value. So big data by itself doesn't make any sense. So I think the better term here, instead of big data, if you could all jump on this bandwagon that I'm creating, is it's not about big data, it's about analytics. So the real term is big data analytics. And I actually will say we should go one step further, because analysis without impact is useless as well. I mean, we could have brilliant insights, but if the business doesn't adopt them or do anything with them, what's the purpose? We've just wasted a lot of time and money. So really the goal of big data, the goal of big data analytics, of BI, and this is hammered home in the book by the leaders I interviewed, is to make an impact on the business. And Ken Rudin of Zynga went so far as to say, you know, my analysts, your bonuses are no longer going to be based on the quality of your insights. They're going to be based on actually moving the needle of the business and helping them achieve their goals. Your goals are their goals. And they pushed back on that. Well, how? Well, we can come up with these insights, but we can't make them adopt it. How can you hold us accountable for that? And Ken said, well, you know, a salesperson can make all the right calls and bring all the right messages and collateral to a client, but if the client doesn't close the deal, do they get their commission? No. So it's the same kind of thing. We need to focus on impacts. And believe it or not, when you change the equation that way and incent people based on impact, not on insights or not on data, they actually enjoy their jobs a lot more. They begin to see what impact they can make. They begin to see that they have a real role to play in the organization, and they get charged up by moving the needle for their business partners. But anyway, I'm digressing. All right, so big data analytics. Not new. A lot of companies have actually put those two together and delivered a lot of value for their organizations. Netflix mines large numbers of purchases by their customers to deliver personalized recommendations about what TV shows and movies they should buy. Zynga, which I just mentioned, they actually mine your playing behavior so that they can give you a personalized experience in each of their online games. So the game that you play is going to be different than the game that someone else plays. At least look different, even though it's the same game. Progressive Insurance, through its Snapshot product, which is a sensor you attach to your car, they'll give you personalized car insurance based on your actual driving habits. And Alliander will mine your energy consumption and enable you to create your own personalized energy consumption patterns using smart meter technology. And those four are very indicative of what companies are doing holistically with big data. And that is, in the past world, we had a mass market, and we would drive one product to all the customers in that market. Today, we've talked about mass customization, tailoring products and services to every individual, but with big data analytics, we can now deliver it. And those four companies are an example of those who are implementing mass customization, personalizing products and services based on individual habits. But that's not all. AOK is a health insurance company. They're mining clinical data, lab data, claims data to detect at-risk patients with multiple chronic diseases and getting them the coordinated care that they need. Vestas is a wind turbine company that's mining large volumes of wind data to better optimize the placement of their wind turbines. Sabre is a large travel reservation network. Okay? They know already, when you book an airline or a hotel or a car, they track all those transactions, but what they don't know is how you got there, how you shopped for that, what things you looked at, what routes you looked at and then discarded, in what order. And they figure if they can mine all that shopping data, they can create some real valuable applications, like the best time to buy an airline ticket between San Diego and Houston on April 22nd on this airline. Global Village, like many government and nonprofit agencies, is mining big data to improve social justice. They've established viral listening posts in various hotspots around the world to detect disease before it becomes a pandemic. So these are just a couple of instances of companies that are using big data and applying analytics and driving impact. And hopefully you're doing the same in your organization. All right, but I haven't defined big data yet. And so now I'm going to turn this back to you, because I'm sure you've heard a lot of definitions of big data. And here are some of the ones that I've heard. So I want you to pick one or two. We'll let it be multiple choice if you want. So is big data lots of data, different types of data, high-velocity data, purpose-built analytical databases, distributed file systems, in-memory databases, a Java Developers Full Employment Act, a replacement for the relational database, or a club for hip data people? Anyone want to venture a guess? What's that?
We're hoping for I.
Aye. Well, you know, these questions, they're always trick questions. So the answer is yes, it's actually all of them, including the snarky ones at the end. So you probably heard from Gartner Group and others talk about the 3 V's of big data: volume, velocity, variety. And yeah, that's describing the characteristics of the data, right? But the data by itself, as we said, is not much value. The next 3 on this list describe systems. So if you talk to vendors, they're kind of thinking big data in terms of the platform it runs on, okay? And then these last 3, these kind of snarky comments, indicates that big data actually is a movement. And I didn't really discover this until I went to my first big data event about 3 years ago in New York. And I walked in, and they were all talking about data and analytics. And then I looked around the room, and I was the only one in a blazer or a suit. Everyone else was in sneakers, T-shirt, and had a ponytail. And then I realized, oh my Lord, this is a cultural revolution. These are Java developers in the open source movement who've outgrown MySQL. And they need a bigger, more scalable platform on which to build their web-based applications. And a lot of what this big data is about is developers, the process side of our companies, discovering data. And my response to them is, great, welcome aboard. You know, we've been here 20 years. Of course, they think it's all new and are trying to reinvent everything we've done for the last 20 years. It's not to say that what they're bringing to the equation doesn't have a lot of value. It does, and I'll show you just where in a second. So anyway, I'm going to go through data and systems. This is kind of a little outline, and talk a little bit about the movement as well in the process. All right, so I've got one slide on the data side of big data, and it comes from Hortonworks, which is one of these new Hadoop companies, Hadoop-based firms. And I really like this slide, which I've modified a little bit, because on this axis it shows the volume of data. This is the timeline, and this is the variety of data, from structured data, which fits neatly into the rows and columns of a relational database, to semi-structured data, which doesn't really, unless we parse it first, and then unstructured data, which really are just bit streams of data, you know, that come from audio files, video files, images, and the like. And what this shows here is our operational systems over the years. And how they plot to these 2 axes. So back in the 90s, what we knew about customers in particular came from our ERP systems, and our ERP systems tracked what people bought, okay, what they put in their market basket and checked out at the counter. That's the sum total of what we knew about customers back in the 90s. But then with the advent of customer relationship management systems, we could begin to track not only their transactions, but the way they interacted with us, okay, through the call center, through email, and through face-to-face interactions. So our profile of customers got bigger because of the data that we were collecting. And then in the 2000s, the web hit, and we started launching websites and e-commerce sites. So now we can begin to track what customers are doing on our sites. You know, what pages they're looking at and what order. It's almost as if when you walk into a grocery store, there's a video camera on you, and it tracks you as you go up and down the aisles. It sees what products you're pulling from the shelves, putting in your cart, maybe which ones you're putting back on the shelves, how long you're spending in the store. That's what we can do on our websites a lot easier than we can do it in our physical brick-and-mortar stores. But some of you may know we're actually doing that in our brick-and-mortar stores now today. And some are actually even videotaping you as you pull into the parking lot so they can get a picture of your license plate and then coordinate or correlate all of your activity in the store with who you are as a person so they can better market to you. It's a little scary, but welcome to the world of big data. And now with big data, we're not only tracking what you're doing on our site, we're tracking what you do everywhere. And not only what you do, but what you think and what you say to your friends and your family through social media. And anywhere you go with your cell phone, we're tracking it. You know, Nokia, which is one of the companies I profiled in my book, uses their phones, all the pings they get from the phones, which ping back home every 15 seconds, to update their maps. They bought Navtech, which is a mapping software. So now they know if a two-way road went one way, they can see that based on, you know, the actual movement of people that they're getting through these, collecting and aggregating all these pings. So the sum total of it is that our notion of customers has evolved from transactions to interactions to observations. So this is the world of big data. And we'll come back to this when after I talk about systems. We'll overlay the systems on top of this map to show you where they fit. But I kind of like this chart. I think it says a lot in one slide. All right, so let's go on to systems. There have been 3 generations of big data systems. Okay? The first generation are those relational databases that we've come to know and love, or maybe hate. You know, the Oracles, the Microsoft, the DB2s from IBM. These were lying around in the 90s when we first built data warehouses. But the thing to know about them is that they were designed for transaction processing, not analytical processing. And they've been retrofitted for analytics, which is good as it goes until you start adding large volumes of data and users, and then they usually start hitting the wall at some point. And unless you're willing to spend a lot of money throwing hardware at them, they just don't work anymore for analytics. At best today, they're hubs to feed data into downstream systems that do your reporting and analysis. Now, around the early 2000s, people began hitting the wall with this first generation of system, big data system, if you will. And there was this collective pain point in the industry. And anytime there's a collective pain point, it creates an entirely new market. And all of a sudden, in the early 2000s, there was a new type of database that came into the market. I'll call it an analytical database or an analytical platform. It was purpose-built, not for transactions, but for analytics, providing dramatically better scalability and availability than the first generation of relational databases. Much quicker to deploy, no aggregates to create, no indexes to build, no tuning. You pretty much load the data and go, especially in an appliance like is pictured here. Not quite that simple, but a lot simpler, a lot faster than the first generation. And these things fly. I don't know how many of you have implemented one of them. I'll show you a list in a second. But they're implementing a lot of new technologies like massively parallel processing, columnar databases, storage level filtering, solid state disks, caching. A lot of new technologies specifically to support analytics. As a result, faster, more scalable, lower cost per terabyte than the first generation. And a nice added bonus is built-in analytical functions. See, with the first generation, if you want to do anything halfway sophisticated with the data, what did you have to do? I'm sure most of your users still do this. You take the data out of the database and you move it into something you can use to analyze the data, like Excel, if you're a business analyst, or SAS, if you're a statistician. Well, a lot of these vendors now are adding very sophisticated analytical libraries to these databases so you don't have to move the data. And guess what? With big data, you don't want to move the data, okay? There's too much of it. And that's cumbersome and time-consuming. So let's leave it in there, do our analysis there. Great breakthrough. They can be deployed as software only. If you have a real sophisticated data center with lots of extra capacity and very strict standards, they can be applied as a hardware-software combination, or even in the cloud. And we'll start to see the cloud really start to pop in BI and analytics this year. So anyway, a big pain point in the industry, and all of a sudden, in the mid-2000s, we saw dozens and dozens of vendors come out with these types of products. And this is a short list here. Now, truth be told, some of them existed before this time, like Teradata, and Sybase IQ, and SAN technology. But most of them were newcomers trying to meet this pain point. And as a result, it was kind of a little bit threatening to the established database vendors, and they bought into this market or built into this market real quickly. And so it consolidated really fast. So I've shaded the companies that were bought or introduced by the big guys over the years. And what's interesting, that I hope all of you are at least evaluating these types of tools, if not bringing them in, because they can really make a difference, turbocharge performance, and add credibility to what you're doing. These guys really didn't get much time in the sunshine before they are eclipsed by this new big data technology, which we call Hadoop, which for many people has become synonymous with big data. And I know there's been a few presentations here of companies that are implementing it. But I told you I went to a couple of big data conferences, and I kept scratching my head thinking, well, what the heck is really new here? I've been doing big data for a long time. What is really new? Well, I finally figured out there's a couple of new things that Hadoop offers, and I want to go through those. The first is that it finally gives us an answer for unstructured data. Now, truth be told, we can deal with unstructured data in the relational world, but not very well. We can import it as blobs or point to it in other files. We just never really had a good answer for how to deal with that other 80% of the data that the business might find valuable to work with. So that was a big new thing that Hadoop introduces. The second thing is that Hadoop is not a relational database. It's actually a file system, just like you have on your laptop or computer. And actually, it's a distributed file system, or Hadoop distributed file system, HDFS. And it's designed to run on a cluster of commodity servers, really cheap servers. And the beauty about HDFS is that it assumes that these cheap servers are going to fail. So it builds in failover. And one way it does that is it requires you to replicate the data 3 times, okay, and spread it across the cluster. So in the Hadoop world, if you have big data to start with, well, it's always going to be at least 3 times bigger before you even get going. The next big thing about Hadoop that's really new is that this concept called schema at read. See, if you're working with a file system, you can just dump the data in there. It doesn't matter what type of data, in what format, or what schema. You just dump it in there, just like in your own computer's file system. You don't have to model and transform and structure the data like you do in the relational world, which is time-consuming and costly. But here's the thing. If you don't pay the piper up front and structure your model, your data when you load it, you got to pay the piper at some point, which is at query time. And that's what schema at read means. It means that when you want to go query, you got to understand what the schema is so you can construct a proper query to go pull something of value back. So in the Hadoop world, what this basically means is that the only people who can get the data out are the people who put it in, because they're the only ones who know what the structure of the data is, especially if you're working with very complex weblog data, which is primarily the use case today for Hadoop. The next thing that's really different is that it doesn't use SQL. And if you've been in the big data world for 20 years like me, you might think, oh, this is radical. In fact, this is kind of foolish. How can you do any kind of reporting analysis without SQL? Well, let me tell you, if you're a Java developer, this is great news, because they hate SQL, they don't like relational databases, they want to do what they do best, which is code, okay? So to get anything out of Hadoop, you've got to be a Java developer. Well, we're actually starting to see some higher level languages come into play, like Hive and Pig, that allow you to access data that are SQL oriented. And in fact, this past week, we've seen a couple of vendors come out with SQL-based access to Hadoop, Microsoft being one and Greenplum being another. Cloudera has SQL-like access. Another new thing is MapReduce, and basically this is an API that shields your Java developers from having to know the intricacies of building parallel programs. All you have to need to know is what parts of the program would work best in a parallel fashion, and it basically takes care of the rest. So it turns an average developer into a really sophisticated developer who can build parallelization programs. The next, and perhaps the biggest thing, is that it's free. Okay? You can download this software that can manage petabytes of data, run it on some servers that might be lying around your company for nothing. So that's pretty compelling if you're paying $1 million, for a database and a system from an established commercial vendor. But I tell you what, this is free like a puppy is free, okay? They're cute and cuddly when you first get them, and then when they pee all over your kitchen floor, you think, what have I created? It's the same with Hadoop. The TCO, I think, is pretty high right now because it's all new and because of the talent you need to bring in to make it work. And the final thing is that you need these very sophisticated people that are being called data scientists to actually work in this environment. And as far as I can tell, a data scientist is a combination of business analyst, a statistician, a visualization expert, and a Java developer. Okay, basically, they're as common as a white unicorn. Okay? They don't really exist, except in Silicon Valley and some places in academia. As a result, they're very expensive. This is where a lot of the cost is in building out Hadoop environments. So these are things that I discovered were really new about big data that this developer gang, this open source movement was bringing into the world of data that I've known for 20 years. And in summary, basically, a lot of benefits here. Very comprehensive, any data, any programming. Very agile, quick to load data anyway. Quick to set up. Very expressive. It's not limited by SQL, which has some constraints for doing certain types of recursive queries. And it's affordable, at least to get going. There's certain drawbacks, though. It's definitely 1.0 technology. A lot of holes in the lineup, like security, okay, management, no concept of joins. And the biggest thing is that it's slow. It's designed as a batch-oriented environment. Now, the community building out Hadoop-based solutions is moving very quickly to plug all these gaps in the lineup, extremely quickly. The other drawback, expertise, these data scientists, and the total cost of ownership. We're still trying to figure out what that really is. Okay, so that's what's new about Hadoop. And now so that was the systems part of the outline. Now let's pull those two together. How do the systems map to this data? Well, that first generation is probably going to be pretty good at handling your structured data into the hundreds of gigabytes. As I said, mostly used as a hub for feeding downstream systems today. These new analytical platforms will get you into the tens or hundreds of terabytes, and some of them will actually help you manage and process and analyze unstructured or semi-structured data. And then Hadoop really can do the rest. It can handle petabytes and beyond, all types of varieties of data. And actually, if you look at this, you see that Hadoop is a superset of all three. And in my opinion, well, in the opinion of some people, the Hadoop advocates, this proves or shows that it can do it all. And it certainly can do it all. You can use Hadoop for anything. It's kind of like the Swiss Army knife of BI. It has a lot of different capabilities, but are any of them best of breed? Okay. Certainly it's good for analyzing large volumes of weblog data that's unstructured and semi-structured. But the thing I'm seeing a lot of companies make a mistake, they're chasing this silver bullet. There's so much hype around Hadoop right now that if you have the least bit amount of unstructured or semi-structured data, the temptation is to say, I need Hadoop. And that's just not true. So really understand what your need is and look around before you get into this very immature technology and take it for a ride. Because you're going to hit some speed bumps along the way. But the basic differences between these are that if you look on the Hadoop side, high latency, which means batch, that's going to disappear eventually. You can store all your data there, low cost per terabyte. Now, if you move left to the other two generations of databases, it's kind of the opposite. Low latency, fast queries, summarized data, more expensive. So that's how the systems in big data map to the data in big data. All right, so now we need to figure out, based on the title of this presentation, now that you know big data, how does this fit into your environment today? What role does it have to play? All right, before we can show you that, I need to give you a framework of what your environment should look like going forward. And it's this. This is my BI Framework 2020. This is where I think BI environments will be in the next 10 years. You see in the middle, all these things are designed to use information to make strategic decisions and support reporting and analysis apps. Again, as I said, two different types of apps. Now, up until recently, anytime we've wanted to help business people use data to make decisions, we've built a business intelligence environment, this section in green. We built a warehouse, we built dashboards, and we delivered reports to users. But my hypothesis today is that we can't shoehorn all of our business intelligence activities into that single architecture. Okay, we need actually multiple architectures. In fact, there's not just one intelligence, there's 4 intelligences. So there's business intelligence, which is data warehousing driven, typically IT driven. Move over to your right, there's continuous intelligence. A lot of interest in operational analytics now. Making decisions on data as it's moving and flowing through your organization. At the bottom, there's analytics intelligence. We've always had that. Okay? These are the analysts using spreadsheets to make decisions, or statisticians. And then to the left is content intelligence. This is applying reporting and analysis to that 80% of unstructured and semi-structured data that we haven't been able to do anything with up until recently. And in between these intelligences are areas that are ripe for innovation. Like the intersection between analytics intelligence and continuous intelligence is decision automation, where we embed analytical models into our operational applications and in some cases automate the decision making, such as for fraud detection. So this is the framework, and now I want to split it in half. So the top half of this I call top-down business intelligence, and the bottom half I call bottom-up BI. And these are two very different worlds, as different as reporting is from analysis. In the top-down world, you gather requirements to understand what questions people have, and then you bake those answers into your data model and your ETL maps and into your reports. But in the bottom-up world, there are no requirements. I don't think this is building the way I wanted it to. In the top-down world, it's really about monitoring business processes and spitting out the results to casual users, executives, managers, frontline workers in the form of dashboards that they can use to basically quickly glance at, see how they're doing. They're not being paid to crunch information, so they really only want to take a glance and, if necessary, drill down a little bit if something's awry. But the bottom-up environment is very different. It's all about exploration and analysis. And this is the realm of your power users, the people who you actually hire to work with data day in and day out, but who aren't IT professionals. And for those folks, there are no requirements because they're answering new questions every day, every week. So the way we address their requirements is very different than the way we address the requirements for casual users in the top-down world. No requirements. So the worst thing you can do as an IT professional working in the traditional BI space is ask the power users here, what data do you want? Because what are they going to say? They're going to say all of it, right? So that's a useless. You don't gather requirements from them, okay? You build sandboxes for them and give them access to any data they want. Now, if you ask casual users what do they want, what do they say? They say, I don't know. Or they'll say, I'll know it when I see it. Okay? So those are the people you really need to build reports for, and you need to have spiral and agile and rapid prototyping methods to tease out what they really want as you go along, because you can't really gather the requirements up front. That's why if your PMO wants, your project management office wants you to build apps like you do transaction apps, you're doomed to fail. All right, so this is a framework in short. Now let me show you the architecture, or I should say the ecosystem that goes with it. Here's our top-down, bottom-up demarcation. Everything in blue is the traditional BI environment with your ODS and your data warehouse and logical or physical data marts and BI servers. Everything else is what's new, those other three intelligences. So up here we have our CEP engine, our continuous intelligence engine that's taking event streams from sensor networks or systems logs or web logs and just looking for aberrations and anomalies and alerting dashboards or kicking off workflows as a result of those exceptions. All different kinds of data sources, semi-structured, unstructured. A lot of that is being fed into Hadoop, which, as you can see here, sits in front of the data warehouse. And it really is becoming the new staging area for the warehouse. Because think about it, the cost of loading data into it is so low. Just dump it all in there and then figure out what to do with it later. If we want to analyze it with our familiar SQL-based tools, then we'll push it into the warehouse. Down here are some of these new analytical platforms or NoSQL databases that are either serving as a sandbox for your power users, working with a replica of data in the warehouse, or maybe they're working with completely unstructured and semi-structured data that can't fit in the warehouse. And we're pushing them onto a separate system to avoid bogging down the performance of the warehouse. These are your new in-memory visual discovery tools, which I just wrote a big report on, by the way, like ClickTech, for instance. Very important tool for power users. And the great thing about these visual discovery tools is they're not only great analysis tools for power users, those power users can then publish something that's of interest to their colleagues in their department as a dashboard that's interactive. And it allows casual users to actually do a little bit of analysis themselves. So that's why that line works there. And then finally, we have these virtual sandboxes inside the warehouse. Because the last thing we want to do is build walls around our warehouse that keep the power users out, which we do, because we're afraid they're going to bring it down with these runaway queries, right? So we lock them out. They get mad. They figure out a way to get the data anyway. And then they start building these spread marts and silos that undermine everything we're trying to do in the top-down BI world with information consistency. So if we give them a little sandbox in the warehouse, or a sandbox here, or a sandbox here, or if you're a data scientist, a sandbox here, we can make them full-fledged players in our BI ecosystem. And to tell you the truth, these folks who have been our traditional enemies, they are our biggest allies. We need to bring them into this community. We need to actually put them on our teams, our extended BI competency center teams, which is a little terrifying. It's kind of like putting the fox in charge of the hen house. But that's what we need to do. They're from the business. They should be driving the direction of our warehousing environment. They're already doing that by telling you, by creating all these spread marts, which are the instantiations of your next generation of data warehousing requirements. So bring them in, start talking to them, find out who they are. Okay, so what's in green are these sandboxes. I call them sandboxes for different types of analysts, as a way to bring these guys into the environment instead of excluding them. All right, so that's the architectural diagram. Let me show how this all works together from a flow perspective. So this is what we do today. We take data from source systems, we ETL it into our data warehouse, and then we query it with BI tools. The mantra here, because the cost and expense of loading, structuring, transforming data is capture only what you need and nothing more, because you'll drown yourself. But with Hadoop, changes the equation a little bit. Oh, I'm sorry. One thing we can do with Hadoop is take all the detailed data that we'd have to aggregate and roll off the warehouse and put it on tape and actually store it in Hadoop. Some people call it the new tape, okay? Because it's expandable storage, the data's always online. So we can do that. But the other thing we can do is start to land all this unstructured and semi-structured in there, because the cost of doing so is so low. In this case, the mantra is, let's capture it just in case we need it, because the costs, as I said, are low. Once we put it in Hadoop, then we'll want to, this didn't build correctly here. Let's see what we got here. Well, you want to figure out what's worth exploring in Hadoop, and then parse and aggregate it, and move it into your data warehouse in a bulk load. And this is the primary use case today of how people are using Hadoop. They're landing weblog data, they're parsing it, aggregating it, pushing it into your warehouse where people can get at it with their SQL-based tools. I'm going to build this out. It missed numbers. There we go. I missed 4. All right. So eventually what's going to happen is that your ETL tools, your BI tools, will actually make access to Hadoop transparent through virtualization behind the scenes. So you don't need to know where the data is. You're going to use your commonly used tools, and they will know where the data is, and they'll actually pull it together on the fly for you. So that's federated querying ETL through virtualization. But we're also starting to see companies use Hadoop for reporting and data mining. Why? Because Hadoop's a batch environment, and those are batch jobs. So it kind of makes sense to do those in Hadoop if you've got all the detailed data, and that's what you want to report or mine on. So those are the workflows that I see today. But they may change. I'm already starting to hear data warehousing managers say, well, if I got all my data in Hadoop, why do I want to move it to a data warehouse? Which makes sense, right? And if Hadoop actually gets real-time query capabilities, which this month it did get, thanks to a few vendors, what do I need my data warehouse for? And so we're starting to hear that from companies like Netflix, which is by far and away on the bleeding edge of anything to do with computing. They run their whole business in the cloud, which is mostly a good thing. Sometimes it's not, like on Christmas Day when their streaming servers go down, thanks to Amazon. But you'll hear guys at Netflix say, in fact, I profiled Netflix in my book. And when Kurt said this, that Hadoop is their data warehouse and Teradata is their data mart for relational processing, I said, you can't say that. You can't say that in my book. I'm a data warehousing manager. Well, it was his words, so he had to say it. And I pressed him on. I said, come on, that can't be right. I mean, how much of your reference data is in Hadoop? He said, well, today about 10%. But in 5 years, probably 100%. And we'll just farm data into Teradata when we want to do some very specific SQL-based dimensional processing. So is this the future? I don't know. It's one possibility for sure. Something to think about anyway. So I think that's actually, do we have time for any questions? One question? Yeah? So listen, anybody have a question here? I actually have a microphone. All right, well, thank you very much for paying attention. I hope you got something out of this. There's a couple of copies of my book outside if you want it. It's also on Amazon. I enjoyed being with you. If I can be of any help in the future to you, I think my email is somewhere in the presentation. I'd be happy to chat. Thank you very much.